Okay, today we'll solve problems on the bridge principle. What are the various problems they are asking in different competitive examinations based on the bridge principle? So, if you look at this small problem, directly it won't appear like a bridge, but we have to identify is it a bridge or not. So, in this problem, question is find RAB, find resistance equivalent across A and B. So most of the students solve this problem like this. They think that this 2 ohm 8J4 will form a delta connection and 2 minus J2 4 will form another delta connection. They start converting delta into star. Both they convert into star. Then simplify using series parallel. Like that, they waste lot of time because of this is the complex value, so 8J and minus J2. So simple technique is, if you observe, 2 into 4 equal to 2 into 4 is equal to 2 into 4 is equal to 2 into 4. So this product of opposite arms are equal. Therefore, bridge is balanced. When bridge is balanced, what is the current here? The current here will be 0. So voltage at this node equal, not same, equal. Here it is 5, here if it is 5 volts, here also 5 volts. This 5 is some other value. So potential difference is 0, therefore current is 0. Current 0 means you can think like this branch is open. When it is open, 2 plus 2 is 4, is parallel with 4 plus 4, 8. So this is equal to 4 into 8 by 4 plus 8, 12. So what is the answer? RAB is 8 by 3 ohms. So this is the simple idea. If you get this idea, you will get answer fastly. That is the problem. Now, second problem, for what value of Cx, capacitor value Cx, for what value of Cx, the current I in the resistor, the I is equal to 0. When this current will be 0 if bridge is balanced. When bridge is balanced, when product of opposite arms are equal. So what is the common mistakes many students will do is R1 into Cx equal to R2 into C1, then Cx equal to R2 C1 by R1. This is the common mistake. Why it is a mistake is this resistance is in ohm, but capacitor values are given in farads. Ohms and farad you should not multiply. So this farads also convert into ohms. That is minus J by omega Cx. This is also minus J by omega C1. So if you multiply now, R1 into minus J by omega Cx is equal to R2 into minus J by omega C1. So minus J by omega minus J by omega cancel. R1 by Cx is equal to R2 by C1. So from this Cx equal to R1 C1 by R. So this is answer. So when you are multiplying, see that values are in ohms. That is very, very important to note. So CX answer. If it is all are having capacitors, how we can do? So in this problem, for what value of Cx I equal to 0? But in this all are capacitors. When all are capacitors, you need not convert everything into ohms, time waste. Simply multiply C1 Cx is equal to C2 C3. So what is Cx here? C2 C3 is equal to C1. This is the answer. So all our resistors cross multiply. All our capacitors cross multiply. All our inductors cross multiply. All our capacitive reactances cross multiply. All our inductive reactances cross multiply. Because all are in ohms. So it should be uniform. All are farads uniform. All are henries uniform. But one is in ohm, other is in farad or henry. Then cross product will not satisfy the bridge balance condition. That is the point to be noted. There is another problem on bridge. It is not directly bridge, it's a bridge principle that you have to observe. So what is given, the diode in the circuit given below as V on, that is on voltage, 0.7. If 0.7 is applied, diode will on. But it is ideal otherwise. The current in milliampere in 4 kilo ohm resistor is. So he is asking current in this 4 kilo ohm. So generally, normally how student will think. So try to make diode open, find anode voltage, cathode voltage. Is it greater than 0.7? If it is greater than 0.7 on, if it is less than 0.7 off. So like that, time will be wasted. So simple idea is 4K into 3K is equal to 2K into 6K. So if you multiply opposite to 2K into 6K is equal to 4K into 3K. So both the sides 12, not 12 equal to 12. That means what? Bridge is balanced. When bridge is balanced, what is the current here? 0. Current 0 means open. When it is open, 2K, 4K are series, 3K, 6K also series, and they are in parallel. So what is the current formula now? By using current division, I can use current division. So 1 milliampere is dividing between, and 3 plus 6, 9. Opposite 9K by 9K plus 2K plus 4K, 6K. So this is nothing but 9K by 15. 15K. So it is 3 ja, 3 5 ja. So what is the answer? 3 by 5 milliamps. 3 by 5 milliamps. That is the current in 4K. What is current in 2K? Same. What is current in 3K? 1 milliampere minus 3 by 5. So all other things we can do, but current through diode is 0. What is the total current here? 1 milliampere. Whatever may be the resistance, this current is 1 milliampere because it is a current source. So current source always gives same value of current. Because bridge is balanced, diode is open, this path is open, current is 0. So 2K, 4K series. 3K, 6K series, this 1 milliampere is dividing between two parts. So simply use the current division and find out. There's another problem again, bridge principle only. All bridge problems I arranged at one place and solving. So all these are already asked. There is gate 15, ECE, like that. So at very high frequency, the peak output voltage V naught in volts at very high frequency. What is the capacitive reactance in general? Minus J by omega C na. When this frequency is very high, what is the capacitive reactance? Very low na. Very low. Very low. Very low means approximately short. Zero resistance path. So this capacitor acting like a short. Because AC source na. AC source. It is having frequency of omega. That omega mentioned in the problem very high. So capacitor reactance is very low. And this capacitor act like a short. This capacitor is also act like a short. But what is another important? 1K into 1K is equal to 1K into 1K. Again, bridge is balanced. When bridge is balanced, we have two options. You can think like this is open. You can also think like short. Sometimes by making open, analysis is easy. Sometimes by assuming short, analysis will be easy. Depending on the problem we select. Here, even though capacitor is short, this current I is 0. Current I is 0. Capacitor is short, but why current is 0? Bridge is balanced. When bridge is balanced, current will not flow. So when current is not flowing, even though capacitor acting like a short, because current is 0, we can think like a open. So when it is open, 1K 1K series, 1K 1K series is asking voltage across 1K. So this 1 sin omega t divided between 1K and 1K. But what is asking? Peak output voltage. Peak output voltage. What is the peak input voltage? 1. That 1 will be divided equally. Na? So what is the answer? Simply 1 by 2. So here 1 by 2. Here also 1 by 2. So that is the answer. This is very peculiar. Find current I in 2 ohm resistor. Find I in 2 ohm resistor. So it is not appearing like a bridge, but interestingly, or if you redraw, it looks like a bridge only. What is the thumb rule for bridge? 5 elements are there. So here 1 ohm, this 1 ohm, this 1 ohm, this 1 ohm, this 1 ohm, 4, 2. So there is a chance of this connection in bridge that we have to cross check. And source is outside, is asking current in this 2 ohm resistor. So let us try, is it a bridge or not? So I am drawing the circuit again here. You can draw any fashion. This is 5 volts. Generally, bridge structure is like this. This is the standard bridge structure. So these are the 4 points. So this point is P. Okay. And this point is Q. This point is S. So between Q and S, there is a resistance of 2. Between P and Q, there is 1 ohm resistor. Between P and S also 1 ohm. Okay. So this point is R. And R and S again 1 ohm. And Q and R. Q and R is also 1 ohm. So now it is same bridge only, na? So P, Q, R, S. Here PR is looking here, PR is visible, but here P and R extreme side is coming. So this S point is like. So if you redraw, you are getting same circuit. And 1 ohm into 1 ohm is equal to 1 ohm into 1 ohm. Bridge is balanced. Then what is the current I compulsory? 0. So answer is simply 0. So if you don't get this idea, keep on simplifying using series parallel, if not star delta, or use mesh analysis, nodal analysis. Lot of time will be wasted. So any competitive examination, not a labor work, it is a smart work. You should get an idea in fraction of seconds, not in minutes. Then you can solve within minute. There is again another bridge application. Find current through inductor. Find current through inductor. So inductor is here. Find current through inductor. So there are many sources are there. One of angle 0, one of angle 0, they are the voltage sources. One of angle 0 is a current source. These are all AC current sources. They are AC current sources. These two are AC voltage sources. Now is asking find current I. All sources are inside. All sources are inside. It's a very peculiar problem. What is VBC? VBC 0 na? Why VBC 0? Start from B, go to C. Minus 1 of 0 plus 1 of 0 is equal to 0 na? So VBC 0 means the potential difference between B and C 0. So it is like a short circuit. The terminal B and C shorted. Then 1 of 0, 1 of 0, they are in series. We discussed it now earlier in source transformation. If this is giving current of 2 amps, if this source is giving current of 2 amps, what is the total current? What is this total current? Is not 4, it is 2 only. This is discussed in source transformation. You have to listen the subject in a order. Randomly, if you listen, you will not understand properly. So this current is 2 only. What is the current here? 1 of 0. What is the current here? 1 of 0. What is the current going from D to A? 1 of 0 only. And B and C shorted na. So definitely this 1 of 0 dividing between J1 and 1. So what is the current I using current division? So 1 of angle 0 into opposite 1 by 1 plus J. 1 plus J is nothing but root 2 angle of 45 degrees. So this is equal to 1 by root 2 angle of minus 45. This is nothing but 1 minus j. This is the answer. You can also solve in other way. What is the other way? J1 into minus j is equal to 1 into 1. Minus j into minus j minus into minus 1 plus 1 is equal to 1. So bridge is balanced. When bridge is balanced, current will not flow. Bridge is balanced. What is the current flow from B to C? 0. So this current will not flow. Here only current of 1 of 0 coming. So accordingly also you can answer. But the best idea is this. Basically, bridge balanced concept we follow if source is outside. Sources are outside. If source is inside, bridge balanced, current will not be zero. I'll give one example here. These things are simple, but you should be very careful. So this is 2 volts, 2 ohms. This is 2. This is 2. This is 4. This is 4. Or I'll take 4 into 4, 16. This let me take 8. So 8 into 2 equal to 4 into 4. Na? So 16 equal. So students think that bridge balanced. If I ask a question, find I, so they will give answer I is equal to 0. I is not equal to 0. And I is not equal to 0, not equal to 2 by 2. 2 by 2, right? If source is outside, if source is like this, if source is connected here, if source is same 2 volts connected here, now this is short. If they ask current here, undoubtedly answer is 0 because bridge is balanced. So when bridge is balanced, source should not be there inside, source should be allowed it outside only. So here bridge balanced concept is not applicable clearly. So best option VBC 0. So short circuit, and this current is dividing between 1 and J. Don't think that sir you told you we use current division only with single source. More than one source is there. How come you are using current division? I am using current division because VBC is 0. So circuit is like a B and C, imagine like a short single current source 1 of 0 dividing between 1 and J1. Like that you have to think. Or J external cross product is equal if you think bridge balanced. So what is the current here? 0. If you think this current 0, then what is the total current flowing from D to A? 1 of 0 only. Na? So 1 of 0 is dividing, this 1 of 0 is dividing between 1 minus J, opposite total na 1 minus J by 1 minus J plus 1 plus J. So minus J plus J cancel, and again you will get the same answer. One plus J is root 2 angle 45. Yeah, this is 1 by root 2 angle 45, not 1 minus. So same thing now here also. 1 minus J by 1 plus 1, 2. So simplify, you will get same answer. This is equal to 1 by root 2 angle minus 40. So either way you can do it. This is a beautiful problem, very confusing problem. So all these are the bridge problems. I solved all bridge problems at one place. So never expect directly bridge is available. That principle indirectly they ask, be careful. Now I stop at this point. We'll continue next class, some capacitor problems. Now I am stopped.